Всем привет.
Howdy.
Давайте я для начала представлюсь. Меня зовут Тимур.
I should probably introduce myself. Name is Timur.
Момент в факте.
Right now, I'm working for a fact,
И
and that's a company also known as Group IB. I am responsible for the development of EDR agents for Linux.
Хотелось бы поговорить.
What am I going to be talking about today?
Случилось.
Well, first,
А,
I want to tell about something that we managed to do in terms of monitoring Linux in user space.
является продолжением.
This particular presentation is a natural continuation of my previous presentation at Positive Hack Days 11.
Какие у нас перед
That is last year's.
когда мы пишем EDR-агент. Рассматривать все вопросы буду как разработчик EDR-агента.
So I am going to talk about all this stuff as a developer of EDR agent.
Процесс, состояние и иметь над ней какой-то
So naturally we need to monitor the system, the state, and what have you. The previous solution that
всеми этими свойствами.
contained the core module and kernel live patching,
Небольшие такие особенности.
it had all the necessary features. However, that kernel module had to be relocated from
Легких, особенно когда
system to system, and if you ever develop drivers, you know how difficult it can be, particularly when you need to support all versions from 3.10 to 6 whatever 2, whichever is latest.
Ошибки в нашем коде, когда мы пишем драйвер.
And mistakes in the code that we write for the kernel driver can actually open new holes for threat actors, which is not exactly what we want.
Может быть, немного натянутый, но тем не менее.
And my last idea here, which is sort of far-fetched, but still, you know, since we develop stuff for Linux, drivers need to be assembled in the machine. This means that source code will be in that machine, which means that research for the attackers will be very easy, particularly if you believe that your code is buggy. Therefore, we decided to develop functionally similar software that will monitor the system, and we want to have fault resistance so that, you know, our software doesn't kill the server and neighboring servers. We also want to have execution threat control so that we can prohibit this or that piece of software from doing whatever. We also want to have high speed and high performance. I think everybody wants that. Monitoring requirements are the same as before, but let me repeat them. I want to monitor process, file system, network activity, and system states. Now that may sound fuzzy, and it is my own invention. So the idea is that of configurations and current logins and other meta information, which cannot be considered atomic.
Закончила на состоянии системы, поэтому сегодня мы с нее начнем.
So last time I finished talking about the system state, so it makes a lot of sense to start with it today.
Жирный механизм, который нам существует в Linux и дает нам.
Now, the biggest, the fattest mechanism you find on Linux that gives you so much information is audit. Audit is great. It has been around for 10,000 years. It has so many software interfaces. And user accounting of various types, various complex events gonna provide, like LSM will give us some complex events, and we'll know about BBF and kernel modules. File system events as well. In fact, it can also be run with flags -W and -S. Now, -S, for example, will spawn syscall events. Those who know about interception of kernel functions or development of such solutions will appreciate that the classic solution is about primarily intercepting system calls, which is exactly what we're going to do. We'll try to develop a simple rule that will monitor for a single syscall exec CVE, right?
Сначала мы упремся в то, что
The first thing we're going to see is that exec VE
история. Но когда мы начинаем запускаться на серверах, когда
on low load machines is okay, but if you're running it on servers where there are lots of syscalls,
это переполнение
well,
аудита.
we'll soon run out of audit buffer. It can be configured for sure.
Нам в колено.
However, it will shoot us in the knee on a regular basis.
Аудит, когда генерирует событие, он генерирует его блокирующим образом.
When audit generates events,
Если буфер будет занят, событие будет...
it does them like in a blocking way. And you know, if the buffer is filled, then the whole system can come to a screeching halt. Then you can say, come on, we're doing good code. So we can quickly clean the buffer up. But if we have lots of events, then audit gets in the way of messages. Now, for every event, audit will spawn several messages. And they share a sequence number usually. When you have lots of events, these sequence numbers can easily get mixed up. So we need to reassemble them. This reassembling is runtime sorting, and it doesn't happen fast, which means that cleaning the buffer up will have to wait.
Аудит в этом плане
And another complication with audit
такая медвежья услуга. Это наличие кастомных сообщений. Буквально
is that it has lots of custom messages. Pretty much any software using the audit function will want to send their own custom messages. The worst thing about it is that these messages tend to be plain text, like key equals value. It's not even JSON.
Проблема достаточно жирная, поэтому сообщество Linux Audit
It's a big issue. That's why Linux Audit Project
его можно найти
has generated this list.
в GitHub. Это
You can find it on GitHub. These are
источники сообщений от аудита.
trusted sources of audit messages.
Знакомиться с ними можно там по QR-кодам. Я не буду на них сильно останавливаться.
You can learn more following the QR codes here.
SSH, там логин D.
So you see things like login, login D, SSH, and so on. These are the things we're primarily interested in.
Раз уж мы там закончили на процессах и поняли, что даже...
And now that we're talking about processes, and we realized that, okay, we're not... we need to monitor processes, right?
Быстренько наткнемся.
How shall we do that?
Наверное, механизм мониторинга в user-space, который нам доступен, это центр.
Arguably, the only available tool for that in user mode is kernel connector, cnproc.
Работает быстро, не
It works over a netlink, it works fast, it doesn't block other functions, and it does provide
объем событий
pretty exhaustive coverage of events,
EDR там могут быть полезны.
which we as EDR people may be interested in.
Можно, опять же, либо
You can learn more about it
либо просто
if you follow the links here, or you can simply look at the event structure it generates.
мы смотрим, ага.
So structure prot event is just a raw buffer, really. So you see all the stuff there. You know, these standards, the usual suspects, so to speak, except maybe for
Процесса.
what was that for com, which is a change in process command. Event core dump is a less usual kind of thing here.
На этом моменте...
What can you do?
Ага, окей, у нас есть клевый пул событий. А как эти
So
события?
we do have this fancy pool events. Now, what do they look like? If we analyze this structure, we will see some scarcity there.
Pit, tagit, pit, tagit.
So we have PIDs
Как вы думаете, этого
and gets, I guess, and UIDs. Is that enough?
Я думаю, что все понимают, что одного пида нам...
That's a rhetorical question. A single PID certainly won't get us far.
В Linux мы можем заглянуть в procfs и вытянуть всю информацию...
So usually in Linux, you can find a lot of information in cnproc ifs.
Не блокирующие.
But since these are not blocking events, what's the guarantee that by the time we've read it, the process will still exist?
Когда
This will be particularly inconvenient
много всяких интересных...
if there are numerous processes running, like greps and gets and bashes and evals running in a single machine.
Что мы увидим? Мы увидим pit.
So we'll see a single PID. This information is not enough.
Процессов мы еще дальше вернемся.
We will get back to process monitoring a bit later. So let's agree that cnproc is a bad, a lousy mechanism. Now let's discuss the file system. The situation is slightly better here.
Небольшого интродюса это inotify, супер старый механизм.
iNotify is an extremely old mechanism. It's available across all the kernels, and it can be used to monitor all these events. I'm not sure you can read it, so let me give you a quick overview. All the main ones are here, like file, open, close, write. Also, others such as access, delete, and move.
Нам будет присылать событие даже на обычный стат. В принципе, круто. А что самое крутое?
Which is not bad. And the best thing about it
удобнейших события это close
is that there are two great ones here, close write and close no write. If you ever developed stuff for that, you must have had this issue of tracking file modifications. Fortunately, we have this one. Like, it's important to know, it's convenient to know if the file was closed with or without any modifications.
Тут даже пида нету.
However, we don't get PIDs here. That's an old issue, you can say. And the way it was circumvented in Linux was this. Fanotify.
Читаем прямо вот по этому QR.
This QR will tell you everything you need to know about it.
Антималварщики и вендоры, которые пытаются...
Lots of anti-malware vendors and operators have been critical
Чем она отличается? Ну, в принципе, к нам приходит все то же
of the old system. And for them, Fanotify was developed.
И FD.
See that it delivers pretty much, it returns pretty much the same fields, but it does PID at FD. In fact, most of them generate PIDs for us. What's FD? FD is more interesting.
Который был открыт ядром для нашего процесса на момент...
FD is a file descriptor established by the kernel for our process
Нужно почитать, какие флаги
at the time when the event was generated.
на момент инициализации этой
We gotta check out
процесса. Это
the flags that can exist for it.
фан-класс, буду говорить класс. Класс
So fan class, class native, class content, and class pre-content. So native is just a simple notification. Class content will return an event after a particular operation has been performed. But pre-content will notify us before you do something to a file.
Во флаг могут передаваться fan report feed.
Note that,
Извиняюсь.
I'm sorry.
Во флагс.
Yeah, right. Flags will collect, say, initializing flags.
Ой, тьфу ты. Я вам извиняюсь.
Again, I'm getting confused here.
Мы можем передавать следующие флаги. Fan open.
So fan open,
Access perm, fan
perm, fan access, perm, fan open, exec perm. These are the flags that can be sent to control.
Флаги, которые позволяют
What's that?
по систему
These flags enable configuration of the subsystem so that when we get an application with an open file descriptor, the kernel will maintain a given system call as long as our software decides whether to drop this event or to allow it.
Окей, мы здесь получили контроль над
Which means
системой.
that now we have control over the file system, which is good, because fortunately we have had to write a kernel module for that.
Нам
Next one, fan report fit, next flag.
итерацию этой подсистемы, но
Will initialize a new iteration of the subsystem. However, it's only available since version 5.1.
который у меня возник.
See, this semi-transparent question I have here, why? I'm asking here, why this events fan create, fan delete, fan move,
Почему они доступны только
and the notify events are only available starting from version 5.1.
в недрах мозга разработчика и Fanotify, но не
Only developers of FA Notify can tell you that. I don't know. I have not been able to find an answer to this one.
Мы получаем
However, with these new events,
которые работают уже с...
we are getting new types of data
Там, по-моему, в ядре 4.9 появились.
which work with new system calls.
Handle. Если раньше нам
I'm talking about file handles.
нам приходит его handle.
If previously we get file names, now we're getting their handles. And it is more convenient in some cases because it enables simpler resolution of paths. If we don't have these paths,
Номер файлового дескриптора, который нас открыло ядро.
we can either use the file descriptor number or use other ways to do that.
Какие недостатки мы видим у этого механизма? Мы
What are the disadvantages of this tool?
Нету информации о процессе.
Again, we don't have enough information about the process except for PID. Moreover, if you decide to set up your observation marks for the file system somewhere in the root, chances are your system will freeze, because it is pretty difficult to, report on all file and on activities related to all the files in the root.
Режет нам как-то возможности. И на этом моменте с файловой системой тут, к сожалению, тоже все. Окей.
So you see that file system is not perfect either. Now let's talk network.
Есть перехват системных вызовов, который фактически нам дает.
So we have interception of system calls, which can give us access. Network on Linux is a bit more complicated.
С поверхностными какими-то очерками. Самый простой способ, в принципе, знать о том, что происходит
let's keep it simple.
На машине, это backup.
In order to see what's happening network-wise,
какие конкретно?
You may want to do libpcap.
По этим ссылочкам. Это просто ссылка на.
Which particular mechanisms are used is shown here, and this links to source code if you're interested. If you're not interested, just listen to my explanation. So you get a packet from the internet, or whichever network really, not just the internet. Then it goes to the kernel. Then it goes to libpcap, then it goes to our agent, and all our agent can do is parse it. Then it is sent to the process. And the same is done to egress packets. Well, we can monitor this stuff, which is not too bad. However, we know very little about the process, and B, we don't have any control over the traffic. What do we do?
Просто продублировал QR-код, ссылка на исходные коды.
So I'm showing here a link to source code in the QR code, and having studied the content of the source code, I realized how PCAP works, which underlying mechanisms it uses. Once I've studied them, I realized that they can actually be leveraged in ways other than those provided in PCAP. That requires, however, studying this particular chart. Do you have any ideas, guys? So this is obviously packet flow inside the networking subsystem of Linux. So I'm showing you a close-up to make sure you identify the right elements that we need.
Смотрите, есть такая еще подсистема внутри нетворкинга, она называется NetFilter.
Inside networking, there is a subsystem called NetFilter. NetFilter enables us to set up our own hooks for different state points of packets, so to speak. We cannot filter them. We cannot filter them in user space.
IP tables.
From that moment on, I will be speaking the language of IP tables, otherwise it will be too much code. But to put it simply, we can configure it through clear IP tables, which pretty much any system has. It would be better to do it through netlink. It's just that, for explanatory purposes, I'll do it like here. So we can start two queues for input and output for ingress and egress packets. And at the time when packets get filtered, see table filter here. So we indicate the interfaces, all the interfaces that we have. And see, I indicate interfaces separately because it makes a lot of sense to do it separately to make sure we understand which interface is related to which packet, so that we don't get confused over time. So these tables, these queues, if you like, they leave a packet on the table and they wait for the agent to either accept or drop it. That's what I'm showing in pink here. So queue bypass works in a way that, if user space, stops sorting out this NetFilter queue, no, there should be a routine that will make sure that network is still up and running. Because, there will be other operations waiting for this one to finish. And it's a good one, isn't it? However, it tells us very little about the process. All the functions you see in the libnetFilter key library
парсить.
We can play with them even raw.
Нет ни капли информации о процессе.
But please note, we don't get any information about the process here, like I said.
На самом деле внутри
Not that much of a surprise, really.
сетевой машины Linux информация о процессе.
Inside the network machine of Linux, process information is usually unavailable. This is a problem we run into even when we develop kernel modules.
Не привязан ни к одному процессу.
The incoming process before it goes through QDisk, he's not linked to any process. It first needs to go through filtration, and only after that it will be associated with the process, but it doesn't have this information before that.
Фильтр должен знать какую-то информацию о нем. Даже
And why should filter actually have this information, right?
процесса. Эта информация есть.
So at the output, this information can be obtained. But NetFilter's objective is slightly different. It doesn't really care that much about process, so we don't like this. So we will put up with this, or we would.
Прямо перед презентацией. Но по сути мы
I'll give you the packet, but not the packet owner.
любым
So we're dealing with a user space library or a user space mechanism, but we don't get information about the process.
Мы получили мониторинг процесса.
So that's what we have in the end. We have process monitoring, which is pretty lousy, and yes, we can develop our own machine that will be monitoring FS,
варианты
Pro CFS.
но мы не можем так постоянно делать. Короче, мы будем терять в точности. Мониторинг файловой системы получили.
Which means that precision will suffer. We can do file system monitoring, and it can rely on the state machine,
Мы получили мониторинг.
but it will be only as good as the state machine can be good, and it cannot be.
Процессе. Вот любой EDR, который не будет давать информацию.
Some network monitoring can happen.
Короче, все эти
But you know what?
существуют.
It doesn't really support proper EDR.
Вот.
This stuff may be good for admins.
Будем с этим мириться или попробуем решить с помощью eBPF.
So let's try offering a panacea, that is eBPF.
Потому что мы не совсем про user space.
I initially thought that eBPF would be kind of a lie because we're not talking about user space here, right? But we can control it from user space, although in fact it will be running in the kernel. For those who don't remember what eBPF is like initially it's a packet filter that came from SD, and over time it developed additional functions. That's why it got E for extended at the beginning. So it developed some additional features, and today it's a full-fledged virtual machine running at the level of the core of the kernel. And you can sort of run this semblance of virtual machine right inside the kernel. The benefit of that is that it is not going to down the kernel because it's a virtual machine. Like your software can die there, but the kernel will continue running. So a BPF program will talk to kernel through so-called BPF map. It's like a hash map which is shared between the user space and the kernel. Not the best way to do it, but everybody's used to that. Fast output of events that we can do here inside BPF, about how we're going to spawn events. That discussion is going to happen later. So we can send stuff through perf buffer, and there is in your kernels, there is another system. Like the new system has some advantages, but let's skip this bit. So I hope this short introduction of eBPF should suffice for the upcoming discussion. First, let's do RTFM to learn what eBPF can do. So this is a split by types of programs, and each program has got its own functions, and it will have its own limitations. Just like last time, we'll be particularly interested in K-probes and E-probes, LSM and C-group. The most interesting element here is LSM. Some of you may even remember what LSM modules are, but we're not going to discuss them now. Instead, let's talk about how BPF programs get access to kernel structures. Now, that's a virtual machine, so you will be wondering, how can they get access? These are two different address spaces, or at least they should be. eBPF programs do not have their own heap, so their address space and their memory control, well, they don't have it, but they can talk to kernel structures through the so-called helpers. Helpers are functions that were designed for eBPF, and they can only run inside the virtual machine. In eBPF assembler, they will be like call functions with numbers.
Я сейчас обозначил вот этих два код-сниппета, которые, по сути, мы...
So I'm showing here two code snippets that we will be using going forward. So let's imagine that we have an abstract event handler that will contain information about the process and some other meta information such as creation time, process path, and so on and so forth.
Других абстрактных событий.
And other abstract events.
Давайте посмотрим на то, как можно этими helperами вытягивать информацию.
Now let's discuss how these helpers can be used to collect information.
Пожалуйста, строчка getMM from task. Нам вернется
getMM from task.
Процесса, который, кстати,
it will return the structure and the MM struct, something I talked about in my
продолжать работать через
one but last lecture.
API, о котором мы говорим.
It requires core API.
Так же, как внутри ядра, с точки зрения...
So the way this code will be run will be very similar to kernel from a software developer's viewpoint. And we're going to get all the information that we need inside the virtual machine. And this way we can actually collect a lot of information about the process. And the best thing about it is that we're getting API of IMA, which gives us hashes of files from the kernel. You know, that's usually pretty difficult, right? Working with file hashes in kernels usually is sick. But it doesn't work in all kernels, by the way, so I won't rather talk about it. So we have BPF, we have VM, we have helpers, we have core E's that enable us to work with kernel structures as if they were regular structures, not as something that's running in a virtual machine. Now let's try emulating iNotify functionality here. Now the best way to do it is to do regular kprobes or LSM cookies. Why not LSM directly? Because we want to make it applicable to all kernels, and LSM is only available for a kernel starting from 5.1. So we're not talking about LSM here, but please do remember that with LSM, we will be able to gain process control rather than just process information. So we get the ptrex structure, which tells us something about the current process or register. And then, you know, with the call convention, we can learn the values that were sent to a given function. See security not create over there, which tells us that a file has been created. And then we can get the node and the den tree and then extract from them all the information we would be able to get in the kernel. So then we do the filling, fill header and send. So naturally it will fill the header with the function that we just discussed, and then it will send to user space through the buffer like I said. And then user space will read this R buffer. So far so good. We've just repeated file creation. So all security cookies we may need in the future, I've shown them here. We need to set kprobes for them all, which means that we emulate this functionality, and this way we get something that's like iNotify, but it does provide us with a lot of process information, which is much better. Something you gotta say about file events and all other events. Security hooks are executed in process context, because they are invoked after the syscall. See, VFS create, which is gonna be run inside the syscall in the process context. That's why we actually have process information. So in line 2326, we invoke the security hook with kprobe attached to it. If it returns a mistake, an error, remember that this BPF program is not the only program running in the system. There can be several LSM programs running at the same time. And if one of these LSMs returns an error and prohibits file creation, then the event we've already created for, file send or file creation will return a false positive. In order to avoid that, we can have, say, a kprobe or correct probe. and check the return code.
Синхронизируюсь как в документации. То есть там код
So this way we'll be in sync.
скриптор и так далее.
So depending on file descriptor, the return code can be either 0 or 1. If we're very lazy, we can use the same function we're using for fs notify
Аргументы, которые туда передаются, то есть
and check the arguments it comes with.
там у нас будет вызываться
So after any VFS call, we can also call fs notify, and this way we can verify
реально ли событие должно произойти или нет. То есть был создан файл.
if an event is really going to happen or not. Okay.
Воссоздать и notify. А давайте посмотрим.
So we've just been able to recreate someone's of notify. Now let's try emulating NetFilter
Не использовать NetFilter, а мы тут
or some such. What's wrong with using NetFilter? And in fact, we're going to use security hooks here as well. What's wrong with NetFilter is that, well, we still want to have process information. NetFilter doesn't help us in this direction. We could possibly combine the two, but that would be too complex.
Не абсолютно все, но большинство security hook'ов, которые нам
Shown here are the majority of security hooks that will provide us with quite exhaustive information on what's happening to the network at the moment. And most important, many of them, or some of them at least, are not executed asynchronously, but rather as part of syscall, which means that we will get process information. Now let's look at network connection happening. So we have security socket connect, which is going to be triggered as part of syscall connect.
В ядре есть две структуры.
Note, there are two structures in the kernel. One is called sock, the other is called socket. As such, they seem to be, separate entities.
Структура SOC короткая.
The structure of sock is for the kernel, and socket is for user space.
Имеет указатель на SOC.
They can be connected, they can have pointers towards each other.
Security Connect.
So during socket security connect,
Должны быть связаны вроде. Или...
they get connected, I think. Or they need to have a connection. Yeah, I guess so.
Значит, мы можем получить информацию.
This means that we should collect information.
Подключаться. Мы можем получить локально.
But where we're connecting, we can also get local address. We can, in fact, have all the information of the process.
Создавать, так сказать.
And
Я буду сейчас... Кто-нибудь когда-нибудь работал в Trace?
Anybody ever used Tracy?
Так называемые submission events.
We are going to create the so-called submission events.
Подтверждение, что они...
That is, events that need to be confirmed to sort of happen.
Security Socket Connect это просто марка.
I will also remind you that security socket command is, a mark of, an event that really happened.
Security Net established. В этот момент мы имеем гарантию.
At this moment, we'll have a guarantee that a connection was established, but we will not have a process. We will, however,
уже вот это застрявшее событие, которое мы создали и где-то там в BPF-мапе сохранили.
Have a stuck event, which is saved somewhere in BBF map,
Соединение установлено, но при этом
which gives us a kind of insurance that network connection is established, and at the same time we'll have information about which process tried to establish network connection. Easy, ain't it?
Сохранять эту информацию. Я уже говорил.
What's also important is how we are going to store this information. I've already mentioned BBF maps, and BBF maps need to have a key and a value. For keys, we can use socket nodes. And socket nodes are associated with user space, and they should have e-nodes. On Linux, everything is a file, and e-node will always be unique for a particular socket. We can write e-node to hash map, then associate process and information from NetFlow to eSocket, to this socket, and then collect all event information like we do with, say, submit net event. So all the information is collated as part of a single event and then dispatched. What can it look like for the network? Only for TCP connections, so we can use bind connect con established, where bind and connect will be invoked as part of syscalls. They do have process information, and bind doesn't have to be part of the picture, by the way.
Для входящих соединений это просто сказка, потому что
For incoming connections, that's bind, listen, and accept,
разработчики
which is particularly good.
установить ассоциации.
Because the biggest pain point for EDR developers, when they try to associate connections to processes, is related to incoming
В
connections.
конечном итоге получаем вот такой вот лог примерно.
Ultimately, we get this kind of log.
Из user space.
We are going to print this log from user space for obvious reasons. And you see that it contains device information, process information, and the endpoints as well. Superb.
Я не туда нажал? Или я туда нажал? Вот что мы получили.
This is what we have.
Повторяем все те же самые действия с сетевыми хуками.
So we perform all the same functions with the security hooks,
Монитор.
and we get
То есть всё, что нам дает ПК.
proper network monitor. All the stuff we can get from BCAP and NetFilter. However, we enrich it with extensive process information. And if we also add the C-group section I mentioned previously,
Так как теперь у нас есть
we do get the newfangled container security, because now
то есть там ноды Кубера.
we have this stratification for individual C-groups.
Но а что мы можем еще вытащить с BPF?
Isn't that good?
Интересная штука. Мы
What else can we get from BPF if it's so fancy?
Тут, кстати,
Well, we can use eProbes.
И был вопрос о BPF.
Previously, code injection was mentioned, and there was a question about BPF, wasn't it?
Пожалуйста, это наш код injection, но не
Here you go. That's our code injection.
код, который будет
Well, that's a code at least.
Называется этот механизм
That will be executed where we want it. It's called uprobes. It can be used as part of BPF. It's available pretty much all over the place,
Возьмем простую сигнатуру,
just a bunch of ports.
переписывание
So let's grab a simple signature,
достаточно полезно.
such as overwriting symbols inside a library and describe it with uprobes. How can we do that? For example,
ШСО, ECC,
we can take LDSO cache
так как возьмем вот DLC,
in ETC.
штука, функция, которая из libc позволяет нам искать,
So we can take this
как правило,
libc6 function and look for DLSIM. Now, this is the function that's usually used for operating,
найти эту
and associate uprobe with it. Finding this function can be done with libc6.
Придется распарсить, но библиотек парсинга
This libc, unfortunately, will have to parse,
мы найдем
but that's not too difficult. There are enough libraries for that. Then we'll find the offset for DLSIM function inside the libc library. And after that, from the user space,
этот символ.
with BPF API, we will be able
Таким образом,
to associate it to a particular uprobe. This way, for the whole system,
кода
we shall have our code execution when a particular function
ультимативная. Она
is called.
делает
It's an ultimate tweak, isn't it? It does enable so many things.
тела всяких хэшей, ключей, паролей и прочего.
So we can get hashes, passwords,
А что самое
keys,
приятное,
I
что мы
mean,
до сих пор работаем внутри
if
виртуальной
properly
машины,
done.
и что это не уронит.
And know that we're still doing it inside the virtual machine, so it is not going to down the kernel or the end process, so to speak.
Обновление libc.
So if we repeat it with every update of libc,
Монитор пользовательского.
this way we will have a bulletproof monitor of user space.
Что мы получили с BPF?
Let's summarize. What do we get from BPF?
Что
We get all the same goodies we would get from the previous tools,
процессе.
but on top of that, we are now having exhaustive process information.
Так как у нас есть
With the new kernels, we also can have process control thanks to the LSM section, which is sort of identical to security hooks in real security modules.
ядра.
We're also partially independent now. Oh, sorry, we have partially removed kernel dependencies.
В большинстве полезных
You will remember that FA Notify
версии 5.1, а тут мы как бы взяли
will be workable starting from version 5.1.
поддержку до версии
But here,
там 10, потому что BPF работает.
we have extended, similar functionality all the way down or all the way back to versions up to 3.2, I think.
Это выдавали контроль, например.
And the niftiest thing is that FA Notify and other functions that gave us semblance of control before, but not file system control. Now we can combine FA Notify functions with what BPF gives us.
И казалось,
So nobody stops us from compiling this tag, right?
но
And you can say, good job.
у BPF
But
есть масса ограничений. А можно, пожалуйста,
BPF has got so many constraints. Can you please raise your hands if you write on C? Do you know what pragma unroll is? Wow, not a hand. Or maybe there are some. So BPF has a kind of an execution time guarantee, which means that BPF doesn't have cycles. Or rather, well, it has some constant cycles, the ones that can be optimized and deployed by a compiler. Otherwise, you will need to use this preprocessor directive in order to tell the compiler that you want your cycle to be running full. So the way it works is that the code or the body of your cycle will be copied as many times as you would want it. Naturally, it only works for constant cycles, but that creates another issue. As the number of cycles grows, the program will grow. However, for old kernels, the size threshold is 4096 instructions, and we want to support all the kernels. Naturally, we can do some dirty workarounds. And by the way, this is something you will have to see a lot. Like, why is my program so complex? Unfortunately, documentation is very scarce. Like, BPF program is too complex. It either means that I'm smarter than the computer, or I got something wrong. How do you know which is which? So, we can break our program down into several subprograms and thus circumnavigate this issue. For example, we can break it down into 3 smaller functions, and each of them can invoke the other one sequentially. Not that easy, though. We cannot specify the sequence in which K-probes are launched, or in fact, any BPF programs. So if you split your large program into 3 smaller functions, be prepared that they will be initiated in any random order. There appears to be no solution to this problem. I've read source code, I've Googled it a lot, I don't see a solution. And the only thing I can find is my own question on Stack Overflow. And the answers suggest that it's impossible. I've also found a way, and the link here is a proof of that. So when BPF programs are loaded, they are saved to hash map. So if we know what kind of hash it contains, we can change function names so that they are launched in lexicographic order. But then if something changes in the kernel, nobody gives you guarantees it will work. So is there a way to circumnavigate that? In BPF, there is a thing called BPF call, which enables you to invoke another program. So you can actually do a daisy chain of them. But BPF telcall is not supported on all kernels, and we want to run on all kernels. And we need to put up with the existing limitations. Another problem we have is CoRare, which I've mentioned already before. And the thing that enables us to compile our program on a single developer machine and then distribute it across other kernels and what have you is all very well, and it does work like magic. It is almost magic. However, it does manipulate relocations at the loading stage in user space. So effectively, so you have a structure which has offset space of 10, and then in our kernel it runs fine. But in another kernel, the kernel will know that the same field has offset of 20. So when the system is when the program is loaded, the offset will be changed, and it will work in a reliable manner. But there is catch here. It requires kernel compilation flag. I guess everybody knows about that. Secondly, the kernel needs to export this information, the relocation information. It's called BTF, which stands for BPF type format. And it contains all the information. about proper relocation. So we need the kernel to know about that, and we need ourselves to know about that. We know about that in when we collect it all, and BPF is sort of associated at the very beginning. Do we have people here working with us? Do export this information? Like, we work for you, remember that. Is there a solution to this problem? Well, it's horrible, just like pretty much everything in the world of Linux. I'm sorry, that was a bad joke. So there is this group called Aqua Security. What they did was to collect all LTS kernels from all versions, and they added compilation flags to them. And they uploaded it all to GitHub. Does it help? It does. Because now we can launch it in various machines, check with this repository, look for the BTF file that we need, upload it, or download it rather, and then restart with the relocations that we need. Now, possibly the best way to do it is to sick the scripts from Aqua Security archive and reduce our BTF file, because these BTF files can range from 20 megabytes to 400 megabytes for sure. So these scripts, they make BTF information smaller in size. So we can combine debug information for our software and debug information for the target kernel, and only specify what we need and end up with a small file. Then we can do it for any type of kernel that we need and end up with lots and lots of small files that we can then manipulate. For example, we can combine them into a single file, or we can download them from a cloud. Though that won't look good on on-prem solutions. As an EDR developer, I'm allowed to use such arguments. Now, if you have full control over your environment, you can just stick to a single design, so to speak. Now, these are my final thoughts. I've looked at it all, and I have a feeling that, I've explained it in more or less detail. I've been feeling that something is cheesy here. Something is something is fishy. In Linux, we do not have a proper API for AVs, which means that everybody develops their own solution. There is no model solution. Like, I can say that Aqua Security is a good one, but there is no... It's not like, we develop a program once and it works reliably in every installation. Well, Linux doesn't work that way, after all. So the message I'm trying to deliver is that in this room, there are a lot of developers. I guess you're doing Linux kernel as well. Otherwise, why would you be sitting here in the first place? And I guess we're here to develop something new. And this, security tools do not need to be proprietary. So if we are making money in cybersecurity, it doesn't mean that we need to, that we gotta be doing only that. Guys, why don't we join hands and develop something that is reliable?
Endpoint security framework для macOS — это отличный пример.
You can, for example, Google for endpoint security framework for macOS, which is a great example of what good system should be like. This is it for me. Thanks for your attention. So the first part of my presentation should already be available following this link. Your questions now.
Супер, спасибо за доклад. Ты поделился большим количеством экспертизы, и видно, что ты структурировал большую...
Thank you very much. You've shared a lot of expertise. I see that you've been able to, put in order a lot of experience. Now, the question I'm going to ask may sound provocative, but I really want to pick your brain.
В Linux нет нормального...
I have a feeling that on Linux there is no decent user space where we can track the activity of other programs, and that's why people say let's use a BPF which transforms security into spaghetti and then apply some dirty hacks to it. I think that your description is good for the whole Linux space. We're either, we either find ourselves in a situation where we develop, lots of dirty hacks for the Linux kernel, or we do the same to BBF. Dirty hacks both ways. As endpoint developers, we need to choose something that is not going to freeze the machines of our clients, which means that we are going for BPF. So what's your take? Well, I think it's all crap, I mean, it's all suboptimal. Now, the problem I see, and again, I want to pick your brain here, Linux says we never, ever break user space. At the same time, Linux does everything they can to change internal kernel structure so that Linux and Red Hat need to contribute their own elements without forking, because if they fork, they will be left in the ditch very soon. So we either need proper interfaces in user space, or we will always be doing dirty hacks. So your idea of joining hands and doing good in user space, doing great interfaces, it's actually such a good idea. But my general idea is how we have stable LSM hooks. I'm sorry, I'm a bit anxious. I forgot to mention here that there is a good example of FA Notify. Well, they do have exposed APIs that give us control and can be used as a monitor. The only problem is that it doesn't tell us much about processes. Nobody stops us from using LSM hooks, in a same kind of scenario. Like on Mac OS, you allow frameworks to load as long as you check their signatures. Nobody bans us from doing something similar, doing it in user space to make sure it's safe. That was my main idea, and this is an exhortation, if you like, a call to arms. Let's do it together. There are companies that are still allowed to contribute to the kernel. Let's do it there. But guys from Astra Linux, you've got so many resources. Help us there, okay? Another short question. From the attacking viewpoint, you have this thing that tracks what processes are doing, but it doesn't provide process information. So you get the information that you need from proc. Can the attacker, do something dangerous, switch to another user ID, do another dangerous thing, and thus dodge your EDR? That's why I said that it is workable, but nobody does that. I mean, it's a crappy idea. Remember what I said previously, everything that's exposed is dangerous. And bids are not enough. Superb. Thank you very much. Thanks for your question.
Спасибо за доклад. Подскажи, а без модуля
Thanks for the presentation.
самозащиту сделать в EDR-агенте?
Can we develop a proper EDR agent for Linux without kernel modules? No. Well, LSM is important. So BPF with LSM, which means that below version 5.1 won't work. No, it all really depends on what you call self-protection. That's an inability, hardening process so they cannot be killed, or at least making it more difficult to kill process. Well, you can fork, for all I know. I think that it's only BPF LSM or kernel modules.
Чем конкретно вам не угодили пиды, потому что у вас есть...
What's wrong? You seem to have a beef about PIDs.
Универсальный инструмент, вы можете получать...
I mean, BPF is a pretty versatile tool. You can get pretty much any information you need from the kernel with a pretty stable API.
Вся trace-подсистема, она довольно стабильна. Там...
The whole Tracy subsystem is pretty stable. That's a stable API. So what's my problem with PIDs when I use them in user space? I think I explained that. Imagine we have a pipeline. Cat, grep, VQ, and so on and so forth. How long will these processes live? how quickly will we get information about them? So imagine we don't have BPF, we are running in user space. How shall we quickly get information about the process if all we have is PID? We'll talk to proc FS. What's the guarantee that the process is still running? And the information I read from procfs doesn't change that much. And moreover, you have information when the process starts and when it ends. No, we don't have this guarantee. And it does have a timestamp coming from the kernel. There's no guarantee there. Come on. The process appears, and then you have another event when the process is over and you have the timestamp. Moreover, you have events between them. So you will be able to see if another process hijacked this bit or not. That's true. But what's a guarantee that the kernel scheduler will schedule our process before the event gets sent? Well, if it's been generated in the kernel, you will read it. Maybe you will read it a bit later, but you will still get to read it. And the question, therefore, is, do you really need real-time protection or not? Because you will still collect all these events. You will still be able to see all these events, and you will see if there was a raise or something. So you do have information on all PID changes. You have information on new processes established and closed. It doesn't sound like a fatal flaw to me. I also have 2 points to make. Before Microsoft developed their Windows Defender, they kept saying that in 80 or 90% of kernel crashes happen due to security products. And now that they have their own Defender, they no longer claim that. But then we understand that Defender is responsible for like 80% CPU usage in idle mode. So imagine we have a server with Kuber cluster where every process is launched in a sandbox. And for this process, all we have is PID. So we see that these processes do something crazy in the file system. How do we prove that what they're doing is alleged event, alleged activity, if all we have is a PID, is a process ID? How about we take this discussion off stage? One best question. I don't know if that's fair. Okay, they say it's fair. Then it goes to you.
Все. Спасибо за внимание.
Thank you so much. If you want to talk,